Once we've compromised a system, if our compromise is an unprivileged account, like just a regular user, we need to escalate the privilege so that we can actually start doing some serious stuff. I mean, there are some things you can do that do not require privilege escalation, but usually you want to escalate privilege. So, privilege escalation is the act of exploiting a bug or a design flaw or a configuration problem in the operating system or in some kind of service or software. The goal is to gain elevated access so that resources that would normally be off limits to us, protected from us, we could access them. In Windows, privilege escalation is usually the primary objective. Now, if you manage to get in with a buffer overflow, you're already there. But usually you don't get in at top level. You usually have to do some work. And it may take several attempts to gain the level needed. We can use exploits against weaknesses in the kernel, the services, drivers, or applications to get our privileged mode access. So some privilege escalation methods take advantage of vulnerabilities in the kernel itself, exploit weaknesses in the core part of the OS. Take advantage of services that are what we call writable. You could potentially change the startup parameters of a service, including where its executable is located physically and the account it uses, and then have it run when it starts in a level that is more than it should. Or somewhere along the path, like in services in the registry and also in the services applet of control panel, it will say to launch this executable, it's in C:\Windows /System32 /something, or C:\program files /something something. You might be able to sneak in a malicious executable somewhere along that pathway, so that Windows, as it's reading the path, just runs that executable. And that happens if you don't put quotes around the pathway. You could also maybe compromise a user application. There are various applications, Internet Explorer, Acrobat Reader, VNC, that have weaknesses that you can actually, once you get a low-level compromise, you can use what we call local system exploits to bypass things like user account control to escalate privilege, because they make improper, unvalidated requests of the kernel of the operating system. And it should be validated first, and it's not. This kind of user application compromise, we typically have to have a level of social engineering, like we need the victim to click a link or open a file. So if we can manage to get a low-level compromise, we could bypass the local Windows user account control, and we would process inject. Like, for example, there's a trust relationship between the kernel and this process, but we exploit that so that the kernel just goes ahead and does something for a lower level process, even if the command is malicious. Maybe there are permissions on the process that are weak. So maybe there are controls on that application that are weak. We could try to inject malicious code into that. Or maybe there are folders that are shared and people put sensitive information into shares and allow everyone to read it. I mean, that's not really privilege escalation. That's just downright bad permissions. Or we could do DLL hijacking, which is a form of this writable service thing. This application needs to use various DLLs, and either we sneak in a malicious DLL in the pathway, or we just replace the legitimate DLL. Or the task scheduler. Task Scheduler 2.0, it does not properly determine the security context of anything that's scheduled. So you could, as a user, schedule a task that when it runs, Task Scheduler does it. The task should not be run, and ordinarily, if you just tried to do it yourself as a user, you would fail because you don't have permissions. But ask the task scheduler to do it for you in a few minutes, And it does have the privilege, and it does not check to see whether or not you, as the originator of the task, have the right. And this is something that affects Vista up to Server 2008 and even Windows 7. And there's a description of the CVE number. Maybe there are patches or misconfigurations that are either missing or they're there, and or there are certain patches that even had vulnerabilities in the patch that could lead to privilege escalation. If you have devices and operating systems that are not Windows, here are a couple of techniques. Mac OS, OS X, there is a boot manager called LaunchD. It's the boot daemon. You could edit that. Also, Mac OS X and, quite frankly, iOS have something called plist. It's a preference list. It's a little tiny table that describes how something, well, the preferences for the process, but it can also describe how executables are supposed to start up, including, we could say, hey, run some malicious code while you're at it. We could change the user and group ID on files in Linux and Unix to run in the privilege of the original owner as opposed to just a regular user. We could also, on a web server, inject web shells, malicious code, to maintain persistent backdoor access and escalate privilege. Here are some privilege escalation tools: Dameware, ManageEngine, Metasploit, SearchSploit. SearchSploit is actually a collection of tools. PDQ, PSExec, which is a command line thing, the FatRat, and here's just an example of PDQ deploy. And so we have this for privilege escalation. And so we can see that it's going to try to escalate using a variety of ways here. The countermeasures? Well, first of all, don't allow interactive login privileges. In other words, I can't sit there at a machine and log in if it's a server, if I'm a regular user. Any data that's sensitive, encrypt it. Give users and applications the least privilege they need to function. Services should just have regular users, not domain admin accounts, not admin accounts. If you are an application developer, you should vulnerability scan, well, an admin can do this, or fuzz, meaning throw all sorts of random input data, see what it does, or stress test an application, see if it will misbehave. Regularly patch and update the kernel of the OS, patch and update your web server, all other services. Change user account settings to always notify, so at least there are pop-ups saying, you sure you want to do this? When something malicious happens. Make sure you enclose pathways to all executables in startup files in the registry, in the services applet of control panel. Put them in double quotes so that nothing can be sneaked in along the path. Make sure that executables are put in right protected directories so we can't change the executable. Same thing with Macintoshes and Apple whatevers. Any plist file, try to make it read-only. Don't allow system utilities or software to directly schedule a task. And disable the default local administrator account. So that's what we need to know about privilege escalation.